Hello, everyone. Welcome to the podcast from IEEE Communication Society. I am Professor Aryan Kaushik, and I have with me today our guest, Professor Yansha Deng from King's College London. She has won several awards. Particularly, she has won IEEE Communication Society's Young Researcher Award in 2022. And also, she has won some Best Paper Awards in ICC and Globecom as well. So with this, I welcome Professor Yansha with us to talk about machine learning and AI-based wireless communications and the applications and how they link to the 6G and beyond sort of services and how we can improve our infrastructure with that. So welcome, Yansha.
Thank you. Thank you for inviting me for this podcast.
Thanks a lot for coming. So we have some questions for you. So first of all can you talk about your research work on machine learning and AI, and what are the applications for wireless communications that you can think of that you're working on in your group?
So I started to work on machine learning back in 2017 with my PhD student. Started from, random access technologies because it's MAC layer, you look at kind of also considering for the physical layer, cross layer kind of optimization, looking at how to achieve the massive access of massive number of IoT devices. And at that time, we work a lot starting with deep reinforcement learning approach, which can look at long-term reward, long-term performance. Here in that example, we are just looking at maximize the total number of users accessing the network over a long period of time. And this turns out to be a very good method compared with the conventional convex optimization because it focuses on just one single time instant. Here we have a method that can deal with a long-term kind of optimization. So starting from that, we work a lot on lots of different learning technique like multi-agent reinforcement learning, recurrent neural network. For example, we considered recurrent neural network for traffic prediction and multi-agent for multiple edge coordination for task offloading. This also lead to one of my grants under the European Commission framework. And then in such scenario, we look at various applications, right? Like unmanned area vehicles, IoT sensors, or XR extended reality devices, how to connect with them more intelligently and perform a kind of network automation across many different layers. Of course, there are many works focusing on physical layer. We have been many focus on cross layer to focus on kind of the user-centric metrics for optimization. So it's quite kind of a long time that we have been working on this, and now we have been starting to work on more emerging technologies to further enhance the 6G framework.
And what do you think about, so what are the current, let's say, status of machine learning and AI for wireless communication? So what are the latest topics? You mentioned several of them. And what are the latest topics that are going on currently, especially when we talk about, our upcoming 6G standards and beyond? And what do you think in the next few years, what the trend looks like? So where we are going to head towards when we talk about machine learning and wireless communications, kind of interplay between these. So what kind of topics are latest and what do we expect in near future as well with this?
So as I mentioned a little bit, starting at that time, 2017, people have been mostly focused on physical layer, lots of work on, deep neural network for channel estimation, for, autoencoder, decoder. And this attract a lot of interest. Of course, right now, part of standardization is consider this into, like training at the user side, training at the edge side for coordination between the models. And then, lots of work has been focused on the how to design deep reinforcement learning to solve various problems, performance metrics like throughput, low latency, massive number of access. All these problems has been considered under the umbrella of deep reinforcement learning. And of course, at that time, you have to design each problem with a different approach. And another thing that was quite actively working on was like federated learning.
Yeah.
And then that was quite a strong interest on this area because it changed the data you are transmitting over the network. Originally, if you look at deep reinforcement learning, you are just transmitting observation actions, rewards to the edge. You can configure them in the edge or base station. But right now, if you look at federated learning, you are going to have model parameters, right? And you are going to kind of configure local training, upload the model parameters to the edge, and then download these edge parameters. So this kind of integration need a new kind of communication protocol designed for transmitting effectively the model parameters, model weights, gradients. So this has been actively working on. There's a lot of quantization work, compression, or more efficient learning. I have been working on asynchronous federated learning, time-triggered federated learning. This all lead to a lot of work, part of the standardization of the 6G, the integrated AI and the communication. If you want to facilitate the AI and the closely, seamlessly integrated communication, how to achieve this. And I think this also falls into a framework, or buzzword they call it task-oriented, where we look at the convergence of the performance. The converged performance, if you want to achieve, how can you transmit more efficiently, less data, in order to achieve the convergence performance, similar convergence performance as what you have done without a wireless channel. And there's a lot of joint communication and a transmission design, a learning design on top of it.
Right.
And of course, right now in the 3GPP, the effort is just started, and you can find document looking at a three-man kind of use case scenario. One is how do you use AI for positioning, estimate the location of the user, and the second, you can look at the bin sweeping. And I also have worked a bit on this, how to sweep the bin more efficient to reduce the time you spend on the bin switching. And maybe in the next time slot, you predict the bin, so you can actually send, just use the bin, optimal bin in the next time slot through the AI technology. And that's one of the very effective solution. And then there is another one, which is related to the channel estimation. And you can use the receive signals that you observed and to perform the channel estimation for line of sight scenario, long left sight scenario. So these are the main cases that have been studied, but I think there will be more effort coming, and it's quite amazing that this is part of the one of the main pillars under the 3GPP framework.
Yes, that's very well put as well.
Yeah.
So just continuing on that, I wanted to ask, what are the bottlenecks that we are aiming for? So, for example, when we talk about, let's say, training our models, using AI, machine learning, deep reinforcement learning approaches. So sometimes it appears that they can be quite complex, and the cost can be quite high.
Yeah.
So what kind of bottlenecks that you think that we are trying to, overcome?
Yeah.
Going the way forward from here? Yeah,
there are lots of challenge, falls from, mostly application implementation perspective. For example, deep reinforcement learning, you need a lot of training for different environments. And if you just get data from one base station, that's enough. That's not enough. For a certain period of time, that's not enough. You have to experience different kind of conditions and environment over, maybe several days, weeks, or even months, in order to be trained for these models. Anyway, it's still based on neural models, so it has to be trained nearly can be tested in various new emerging environments. So this is one challenge, and this lead a lot of computation effort. And also, only when the training is done, you can safely deploy it. So that's why there are a lot of topic looking at the digital twin, network digital twin, where you want to digitize kind of everything so you can perform the training in the digital twin rather than just directly trying it, collect data and perform, because it require the real-time interaction with all the UEs and all the environment surrounded. So it really kind of has to be designed to be a more safe way so that the companies would be willing to use it. And of course, the second thing, federated learning is another trend where all these models that we are dealing with are quite large, and depends on what neural models see, and more complicated the model, the more you need to transmit. And how would you reduce the latency for computation, right? And right now, with my collaboration with some companies, it's still in the early stage, even though research community have been actively studying on federated learning. But actually, there are a lot of practical problems like heterogeneous data, heterogeneous device with different computation capability. There are staggering issue. A slower user has to be waited until all the models are uploaded. So this all need to be dealt in an autonomous way, so that the base station can configure all this uploading and downloading, in time or on time, to reduce the latency required for, convergence performance, convergence time. So this kind of research area is quite important, needed for the collaboration among many different, academia, industry, to actually make it work in the real life. So I think we have a lot to be done in that direction. Yeah,
because you see that cost and complexity are really big bottlenecks here, and also how to make it more efficient, let's say for the general usage, because AI for sure, some sort of automated approaches would be used in 60 services. So how to really integrate it into our current infrastructure, keeping it more secure, private, resilient as well, is quite important.
Yes.
So that's very good point that we discuss. And also we hear about large language models or generative AI. So these are also being put through for advanced sort of AI applications. And we also talk about maybe goal-oriented semantic communication as well, how machine learning and AI can actually enhance the objectives that we have in the semantic communication. So do you have any thoughts around this?
Yeah, so I think this advancement in AI really helps us to redesign our communication system. So because right now, if you look at the traditional bit-oriented system, we are just sending all the image data or the video data, transfer it into bits and deliver over the standardized system. And in this way, we are just looking at the throughput performance, latency performance, capacity, and we are almost reaching the limit. And we cannot surpass this. And what we need to do right now, because Shannon lead us to do a lot of great research on this area, but we also need to think other two levels that he mentioned that we didn't spend too much effort on, is the semantic level and the effectiveness level. Specifically, I want to start with effectiveness level, because effectiveness level simply means like when one machine communicates with another machine, there's a purpose and there's a goal. So you want to achieve a certain goal for this communication, right? So for example, if you want to send a command to a robot, you want them to pick something, then the goal is to finish this task, right? But how to achieve this, how to evaluate if your communication is effective, you need to look at the robot behavior along with the communication protocol. We cannot just send all the data without considering the context.
So it's about how you train the model with iterations.
It's also looking at the data behind the data. what is the meaning of the data.
Right.
For example, if you ask a robot to go left and right, do we need to send go left all the time if the command is always go left, right? Maybe we can save some bandwidth and reduce the congestions and reduce the delay as well if you send some important data. So this goes back to semantics, right? You want to send those important data that will be helpful for the receiver to perform a certain task. And this task can be, image recognition task. It can be learning task, federated learning task. It can be, pick and play. All these tasks has to be evaluated from that effectiveness level. And then you reversely design the semantics on what information you can transmit. So one other example we have been working on is you have this avatar and it's dancing avatar. If you just send as the bit-oriented framework, you will send all data in point cloud, right? In the 3D, so it will be 10,000 points you send over every frame, which is a lot.
Complex.
Yeah, very complex and a lot of delay. But what we did is because we are looking at a dancing avatar, why don't we just send the skeleton of the avatar for each frame dynamically? So that you just send this avatar, but you have the base knowledge, like the avatar shape. Is it a superstar? Is it some figure that you already have the base knowledge you send in advance? The background, the chairs and everything you send in advance. Then at the receiver side, it has the brand, has the base knowledge. It can recover from these key points you send over the network. And actually the quality of experience, the video you see recovered from this transmission is much more clear than sending points. The reason, because if you send 10,000 of points, and we are comparing with sending 25 skeleton, and the points we send are less, less congestion you can see, less delay, and also because we have this kind of rough skeleton structure, so you can recover it better rather than relying on the avatar's detail, like the color of the eye. You already have this base knowledge at the receiver. You just recover from the key points, the posture of this avatar. You can nicely recreate it, the 3D environment. I think this solution, goal-oriented semantic solution, is very effective for high data rate and low latency applications. So high data rate, adding like metaverse, holographic kind of applications that requires a lot of data, dynamic data. It will be very good for such kind of, applications.
Yes.
And then also for control and command data, people have been looking at, joint communication and control, send less command, looking at the meaning of this data, the effect on the robot, and then send it more effectively. So eventually, the robotics community, they want to see the robot can achieve the task. They don't care what you send over the network, right?
Yeah.
They want to make sure that, they finish this task, finish another task, they finish a train of tasks according to the design of the transmitter. So in such way, what we transmit can be more efficient. And this can be powered by AI. You can integrate different, transformer, generative AI that you mentioned, large language models, because there are many commands is coming from humans sending a command, maybe from the transmitter side, ask the robot to do something. And how would you translate this to robot, right? Are you sending text? Are you sending command, left and right command or rotation command? Or you sending something different? So there are a lot of variety of research can be done on this area. And for the metaverse, also it's kind of emerging. Our devices, XR devices are emerging. In such a scenario, generative AI is a perfect kind of candidate.
Yes.
Because you can, skeleton is one example. You can have a basic information from an image or from a video or text description of something of the video. You will be able to just send maybe the text, and then you recreate the environment at the receiver. So you can see that right now, because we are in such a diverse use case, we cannot just look at everything independently. We have to join the design. We have to look at the use case, different tasks, different applications, and design goal-oriented semantic comp for each separate task. And something that you are really, strong at the sensing part, the sensing task, integrated sense and communication. Eventually, you are sensing some information from the data you get. Is it radio map? Is it, some other data? Then you can abstract information like human behavior, or some location. All this data can be observed. And it all falls under the framework of sensing and communication.
Yeah.
And I think you have a lot of kind of experience working on this topic. And maybe you can also talk about your opinion on this. Like, how do you see integrated sensing and communication, as well as NTN that is quite related to robotics, and how the AI and also connect with the 6G MIT 2030 framework on these two topics?
Yeah, I think, it's a very good point that we touch upon. So, keeping in mind that we have these user-centric enhancements, this environmental monitoring and, other edge computing-based solutions, AI-based solutions, we can have all this, but we need to remember that it's cost efficient as well. So this is one of the main goals, because, many promises were made in 5G, but not really fulfilled, I would say. But, dealing with 5G Advanced or, going forward to 6G. So we need to also keep in mind that we can come up with, massive networks, use of a lot of automated algorithms and stuff. But we also need to remember that these are cost efficient and energy efficient as well. And again, as you mentioned on the standardization aspect and the framework, 6G framework that we have, that we call it IMT 2030 framework as well. So if you see that we do have various multifunctional sort of integrations already. So as you mentioned, of course, AI is going to be implemented for communication, and maybe vice versa as well, that you can have some communication principles and fundamentals to enable AI. So let's say in the case of over-the-air computing or some other examples. Then the other enhanced capability that we have with 6G framework is integrating sensing and communication, as you also mentioned. So the idea is basically to combine two operations together, either in one network. So let's say if you have coexistence of your sensing device and of your communication device as well, or equipment as you have, and then they are under one network. They are coexisting, cooperating with each other to give the both the multifunction sort of outputs. Or you can have them on the same hardware as well. So basically, you use a dual function signal which carries sensing information and communication information as well. You're saving on the hardware, and you're also saving on the spectral resources as well. So you can use, let's say, one single frequency to operate both the tasks. Let's say if you have to detect an object, a target, and at the same time you have to communicate through a mobile phone, through a smartphone or whatever. So the idea is that you want to make it cost efficient, plus you want to save on your resources, and you want to have multifunctionality as the sort of outcome of doing this. And again, with non-trusted networks as well, as you mentioned, is another enhanced capability, because you have, you want to provide ubiquitous connectivity, global connectivity. So especially if you are, so we are shooting this in London at the moment. So if you are, let's say, going to some rural areas or remote areas, or even when you are, let's say, in the underground, even in the central London, you may lose the connectivity every time when, you don't have access to base stations, the terrestrial network, you don't have access to that. So in those scenarios, flying platforms or having, direct access from satellite to a smartphone might be a good solution to overcome this problem. So basically, as you see in the 6G framework, we have connecting the unconnecting is one of the key objectives as well. That can be fulfilled with integrated sensing communication, aiding non-terrestrial networks. So for example, I would like to touch on one use case. So let's say if you are having, unfortunately, a disaster, let's say, in southern Turkey, it has happened very recently. So we were also delivering a tutorial there. I remember we talked about this. And if you want to, let's say, apply some sort of, technological advanced solutions to assist in that sort of disaster affected region because they, let's say, lose control with the, lose connection or connectivity with the base station or any control center unit which was, giving the connectivity to that area. But now you don't have that because there is a broken link. So in those scenarios, you can send in your drones, or you can, have coverage from your satellites, or LEO satellites are a good candidate. So you can have direct, access to your smartphone through that link. But again, we need to remember it's not just a communication link. It is both like a sensing and communication link. So basically, you also want to detect some objects in that disaster affected area which are lost, let's say, or let's say there might be, some people with wearable sensors. You can also, sort of detect them as well. You can sense that information, pass it to your flying platform or your satellite, and then they can relay it back to, I don't know, some other terrestrial network or base station that can take control of the situation. So really, it's the integration of different technologies.
Yeah.
And I do think that AI will also play a good role in this, because let's say if you want to do resource allocation, as you were also mentioning, that when we want to, let's say, have these inter-satellite links on an edge plane sort of thing, and you want to, store some computationally inefficient sort of data onto a cloud, let's say, and you want to, also have the connectivity with your ground network, with your, remote areas, disaster-affected areas, or some sort of marine areas, or anything that is on the ground user plane. So what happens here is that you can have intelligent resource allocation in this scenario. So basically, you use edge computing and cloud computing, and you try to make some optimization where you reduce the energy consumption, you reduce the delay as well through the deep reinforcement learning approach. You train your model, you train your algorithm in certain way that the computation and communication resources are used quite efficiently in such a scenario. And again, I mean, if you want to use, you can use a dual function signal. You can carry, some sensing metric and communication metric to kind of enhance the performance, depending on, what kind of capabilities you really want to enhance, because there is always some sort of tunability factor, because when you're using a joint sort of signaling, no matter which scenario, you're aiding it with AI or some intelligent meta surfaces or some other sort of dynamic approaches. In any scenario, we need to remember that for the dual function signaling, we need to make sure that both sensing and communication are having like a balance of the sort of performance. So it's not that we put all our resources into making communication very efficient, but we forget about sensing, or the other way around as well. So we need to make sure that the tunability factor is there, that we can tune in depending on our, application. So if sensing is your main task, communication is complementing that. You give most of your dominance to the sensing guy, and then vice versa as well. If you're dealing with the communication assisted sensing model or sensing assisted communication model, you can play around with the tunability as we see. So also, let's say when you mentioned about 6G framework and IMT 2030 sort of framework and standards. So considering the key objectives, we consider integrated AI in communication, sensing in communication, and ubiquitous connectivity as well through the non-terrestrial networks. And in terms of standards, we see that from, since release 17 of, 3GPP, you can see that NTN was already introduced. Even though it is not a super new technology, it has been existing for decades. As you are aware, you use, UAVs, semantic communication, and many other applications. But we do think that this time it has come with a strong force. So this time we can actually see, at least some initial applications we have already seen. So in emergency SOS services. So let's say when there was, Apple was using Global Star satellites to provide emergency SOS services, then Qualcomm with Iridium satellites. Then there are some other, real world examples as well we can see around us. These are early set of applications, but we can see that the growth is quite in right direction, and we expect that the global revenue of NTN based technologies and services is just going to increase now onwards. And you see that in release 17, 18, we have seen non-terrestrial networks, we have seen some network management solutions, AI, machine learning, edge computing have been like a major sort of parts of different RAN groups, cloud native AI applications. Now generative AI is also coming through. Now in release 19, the early study items are considering all of this again, and also more advanced approaches in these. Yeah. And communication sensing core design is also being considered in release 19 of 3GPP, with 32 industry use cases already defined into this. And also, I remember now that when you were mentioning robotic applications, so sensing and communication has very good sort of future in this, because let's say if you want to operate at even some high frequency models, terahertz or sub-terahertz sort of frequencies, you can actually set up some sort of prototype as well. So Huawei had also published some. You may remember that they had published some very recent sort of article on how terahertz and ISAC can be deployed together, let's say controlling sort of robotic arm. And you can also use some sort of multimodal and AI based approaches in this to train your model perfectly, right, to sense the environment and do the environment monitoring and so on. So it does look like that we are heading in the right direction, considering all these points. So I also wanted to ask you about, considering these 3GPP sort of, standardization activities, and there are many pre-standard activities as well, from ETSI, they have different industry specification groups where they work on these aspects. So what do you think going from here, what will the future look like? So let's say when you have, AI-based approaches, you try to train your models with less complexity, you try to, model your channel or optimize your channel, estimate your channel in a way that is more efficient as well, using deep learning or some neural network modeling or, some other AI or machine learning based approaches. So what do you think, like what is the future, let's say, going forward from, whatever is going on now, and what do we really expect?
I think, this is a very good question. From my personal perspective, right now, what we have been focusing on is just different blocks like data connection, chaining, inference, and the models exchange transfer between two nodes. But if we look at, look at the current commercial devices like Ericsson, Nokia, most of the devices, base stations, they are kind of closed. So it means that you cannot get the data as what you want. And on the other hand, you find lots of companies, SMEs, working on, AI for Open RAN, AI for automation. They will face the challenge of the interface. That's why we have been talking about open interface a lot, network exposure of the data to the external, third party kind of, or even like all the community members can just program openly. And this will be a trend if we really want to make this area to boost over the years. But the challenge, of what interface can be opened, there's a lot of security issue, right? The more you expose, even the sensing part, the more you will have more security problems. So how did you make it more secure? Even still secure, but you actually have the data to be open to some of the programmers so that they can configure the system. Like deep reinforcement, we are talking about observations, actions. We're taking the data, right, at RSI or like the received signals as well as the throughput data. This can be quite important, and they might not want to be shared for everyone. So then how can you make it secure? This is one problem. And second, there is interactions between the user and edge, especially for federated learning use case. You are dealing with so many applications, heterogeneous device, heterogeneous computing platform. They have a different computing capability. How would you talk to the users? When should they upload the model? When did you request this? When did you download the model? And the user should be ready to receive this. So this protocol of communication to enable facilitate the AI is not exist yet. At least it's not standardized.
Yes.
We can simulate in the paper, but not actually deploy it.
And do you use several approximations? I mean, practical industry people might say this.
Yeah, this is not practical enough. It's important. You look at 3GPP kind of existing framework, existing protocol. MAC layer, physical layer, and then on top of that, how would you change? Right? Eventually, we are going to evolve from 5G to 6G and future Gs. It has to be based on what we have already done. So taking with all the manually configuration already designed in the 3GPP, can we have some way open some data to the programmer so that we can configure them autonomously? So this is a very big challenge. And not to mention all this problem with when to do the training, when to do the inference, these all need a lot of kind of discussion with the UE and the base station and a lot of protocol to facilitate. And I don't think any of the things has been tested, or implemented in current commercial platform.
Right. And you think that might be the future sort of development sort of area for industries to pick up on?
Yeah, I think there are a lot of startup, starting to work on this area. And I believe the more open the community is, the bigger progress we will make in this area. If all the company just have everything by their own, they don't open what the base station is performing, then we will not be able to implement our algorithm. We will not be able to get the data.
Yeah.
We will not be able to interact in real time.
But Yansha, I think this is a problem with security as well, as you mentioned earlier.
Yes.
Because if you really have like sort of open network, for people to gain access to, you don't have really a secure enough or private enough or encrypted sort of data transmission.
Yeah.
So this could be an issue, I think.
Yeah.
Because especially when we talk about, let's say, non-trusted networks, it is a big issue.
It's more security. I was trying to ask you about the security.
Yes.
How, security issue is more from the government point. Satellite, everything is
even from the
serious,
regulatory bodies. I mean, for them, I do believe, in my opinion, is the spectrum is one of the biggest issues at the moment, because the spectrum reuse or co-channeling with the, let's say, how to say, so if you have, let's say, a link from your satellite, that has to be harmonized, that those frequencies have to be harmonized with what is on your ground network. So your current cellular network has to be harmonized with the non-terrestrial entities. So this is a big challenge.
It also means open, right? What to be shared. If you want to perform learning like handover between two network, there is a permission request.
So even if you have, let's say, one satellite, so it can have wider coverage on different regions. So let's say if you go out of London, it can also cover maybe Surrey and some other areas as well. So different regulators or the compliance guys need to make sure that when the mobile phone, like a roaming sort of case, but you're having direct access from your smartphone. So if you're moving from one region to the other, do you stick to the similar spectrum band that you have for your ground network, and you are able to use the same spectrum for your non-terrestrial network-based connectivity or not? It's not really clear enough how this co-channeling is going to happen. But this is one of the challenges, in addition to the security, as you mentioned. This is also one challenge, because let's say if you have like a drone or flying platform going in the air, it can be even HAPS, but anyone can detect some of these flying platforms and may have these as like sort of malicious sort of activities and so on. So you need to have some sort of jamming solutions as well to block this scanning of your flying platforms and so on. So I do think that there are many challenges.
How do you trust the decisions made by the AI, right? How did you evaluate they are doing to achieve the performance you want? I mean, for those scenario we talk about drones, they are safety related to human, related to the government kind of security. How do you make sure that they are, all the data you expose to them will not be leaked to other partners, and also like other drones or other base, they can pretend to jump this data and to be generating kind of fake data to destroy the models as well. So there are a lot of AI works.
So I think there has to be some ethical considerations as well when you talk about implementation of AI. I mean, you see in UK's, really taking effort forward in terms of AI safety and trustworthiness as well. Exactly. But I don't know how they are going to really implement this, because AI sometimes may get out of control. I mean, depending on, because you have trained your model. I mean, it gives its own outputs as well, and you don't know what is really going to, happen. So, okay, we restrict ourselves to communication-based applications, but you do see that there are some issues and challenges that we are actually facing when we try to implement AI and, machine learning and, several other similar methods. And Yansha, so I also wanted to ask you, so are there any activities in ComSoc that are going on machine learning and AI?
Yeah, so there are two committee, emerging community. One is the machine learning, traditional machine learning for communications and networks. And the second one recently been proved is the generative AI you mentioned. These two are, one is more like, we have been several years working on machine learning, and there is a conference recently happened in Stockholm. The first conference focusing on machine learning for communication networks, and I think we will have more every year around summertime. And then for the generative AI just started, I think they just posted some of the best ratings on these areas.
Right.
The large language models is part of that domain as well. So on top of that, they might organize a lot of workshops, meetings, conference as well in the coming years, as they just started recently. And I believe it's a big potential as well, because of many companies are really, really interested in pushing this forward. And I think in academia, they are also, we also started to work on this as well. I think it will change, everything that we have been used before.
Us.
Yeah, the communication design we have.
Even metaverse applications, I remember, can be based on various new AI sort of models.
Yes.
And it's very interesting because I have this Oculus at home. So sometimes you try to put that on, try to think that, not like a nerd, but you try to think what can be, more advanced than this. So several AI models can actually, so you can have like a sensing, communication, computing sort of or control sort of thing together, many things combined together.
I think, like one of the things, you probably heard of the Nerve, where they can just get image from different camera, like what we have now, and recreate the 3D environment. And this is, we need to actually work with, also the computer vision community along with AI community, and the communication design together to make it facilitate those emerging applications like metaverse.
Yeah, that's great. And we have many activities, as you mentioned, with the conference. So we were both in the organizing committee. Now I remember of that conference, the first one on machine learning for comms and networks. So I think that's a very good initiative. And definitely you are very active in the field, and several colleagues as well, working on the field. So we do assume that, we will see a bright future of the topic for communication and networking, especially. And hopefully we see more of these activities and workshops and conferences and, papers and best readings and so on. So we really hope that we get to see more and learn more as well from these resources. So with this, I would like to thank you, Yansha. It was a great discussion. Thank you so much for taking time out and meeting us today. And hopefully we will meet at maybe another podcast for Communication Society next time, and maybe we discuss all these new ideas and developments that your group is doing, and hopefully we can talk about that as well.
Thank you
so thank you so much for coming, Yansha.
Sure.
Thank you. Thanks a lot.
Thank you.